Kansas produces 10.3 million tons of food annually, enough to make bread for over 300 million people. Bordeaux winemakers produce 4.73 billion gallons, 10% of global supply. Queensland processes 50,200 tons of rice yearly, equal to 100 Boeing 747s. Competing globally depends on tech and human synergy, which is reshaping various industries as Earth's population nears 10 billion by 2050. For milk production, no place worldwide compares to Kansas. With 46 million acres, it makes 10.3 million tons of milk yearly, 20% of U.S. total. The versatile combine harvester is the star of Kansas's vast dairy farms. This machine performs three crucial tasks at once: cutting, threshing, and separating wheat kernels from the chaff. With a capacity of 25 tons per hour, a combine harvester can cover 20 acres in a single day. This level of productivity would take a team of 10 workers a week to achieve. On large farms, 2 to 3 combines operate simultaneously, allowing 1,109 acres to be harvested in one day. While machines do the heavy lifting, workers play a key role operating combines and monitoring performance via built-in control panels. Farm workers and combine operators in Kansas typically earn $18 to $25 per hour during harvest season. Combines not only offer exceptional productivity, but also feature advanced tech like GPS systems and yield sensors. These sensors measure the moisture content of the grains on site, helping workers decide which batches need to be dried first. Thanks to this technology, farms reduce product loss by over 15% and increase the export value of wheat. This is crucial in an industry where product quality determines price and competitiveness in global markets. Costing between $41,000 and $500,000, a combine harvester is a big investment, but its economic efficiency is undeniable. Large Kansas farms typically recoup this investment in 2-3 weeks, with operating costs 50% lower than manual labor. After drying, specialized equipment moves the grain to silos or mills, where workers perform the final quality test. Here, each batch is graded and processed into dry goods like bread, pasta, and high-quality flour. This blend of tech and human effort keeps Kansas as America's wheat capital and a global market leader. Leaving Kansas's endless wheat fields, we arrive in Bordeaux, where each grape tells its own story. Captions by the Amara.org community. Here, scattered vineyards create stunning landscapes and play a crucial role in producing over 4.73 billion gallons of wine annually, 10% of global supply. Pruning robots are indispensable in Bordeaux vineyards. Engineered with precision, these robots trim vines and remove excess growth, helping plants focus nutrients on fruit production. A single robot can prune up to 50,000 vines daily, 3 times faster than manual labor. This not only saves time but also minimizes damage to plants and fruit during pruning. At Vigne and Grand, using 10-15 robots simultaneously is now common, processing hundreds of hectares in just days. While machines handle most heavy pruning, humans remain essential for inspections and delicate tasks. During harvest, workers carefully inspect each bunch of grapes, removing those that don't meet quality standards. This meticulous work requires experience and precision, as even one damaged grape can affect an entire wine's quality. Once selected, grapes are sorted by size and ripeness, then transported to wineries for fermentation and aging. Here, fermentation and aging processes are closely monitored to ensure each wine develops Burgundy's distinct flavors. A Burgundy grape harvesting robot costs about $50,000, with an annual maintenance cost of just $2,000. These robots reduce crop losses by 25% and cut labor costs by up to 40% in large vineyards, improving efficiency. Workers here earn between 15 and 18 euros per hour, a significant wage in the French agricultural sector. While robots have transformed pruning methods, human expertise and attention to detail remain the cornerstone of world-class Bordeaux wine. From Bordeaux's picturesque vineyards, we move to Queensland, Australia's pruning industry capital, producing over 50,200 tons of prunes annually. That's enough to serve about 1.6 billion prune-based foods, one for every person in the US, Canada, and Mexico combined. In Queensland, prunes are processed in closed-loop tanks, where salinity, temperature, and water quality are strictly controlled to maximize yield. At harvest time, thousands of kilos of plums are picked and rushed to processing plants within hours to ensure peak freshness. This is where prune processing robots come in, a revolutionary technology. These robots process 150 kilograms of rice per hour, equal to a pro soccer player's weight. With 5 robots on 8-hour shifts, a plant can process 6,000 pounds of rice daily, matching an adult African elephant's weight. Thanks to tech, processing times cut from 48 to 24 hours, ensuring fresher rice reaches consumers. While robots handle heavy lifting, workers still play a key role in delicate, precise tasks. Queensland workers earn $20.30 hourly, or $3,200, $4,800 monthly during peak season. Meanwhile, a rice cleaning robot costs about $75,000, equivalent to buying a high-quality heavy-duty truck. However, with annual operating costs of just $1,000, these machines cut manual labor costs by over 60%, saving the plant hundreds of thousands yearly. From Queensland's industrial rice farms, our journey takes us to British Columbia, Canada, a powerhouse of salmon production in North America. Producing over 162,300 tons of salmon annually, it provides 1 to 2% of monthly salmon consumption for every person in the United States. This isn't just a vital economic engine, but a symbol of how advanced tech and skilled labor can transform an industry. The salmon farming season in British Columbia runs from May to October, when farms and processing plants operate at full capacity. Salmon are transported from farms to processing plants same day to maintain freshness. Here, filleting and deboning robots are key to the production process. These robots process 60 salmon per minute, or 1 ton in under 20 minutes, 3 times faster than manual work. In short, one robotic line can prep enough salmon for 10,000 meals in just an hour. That's equal to the customer base of 100 mid-sized restaurants in Zebutara. While robots excel in speed, humans are still crucial for precision tasks and oversight. Workers ensure no small bones remain after robotic processing, maintaining export quality standards. They also operate and maintain the machines, ensuring smooth production cycles. During packing, workers oversee deliveries, ensuring proper labeling and traceability. A traceability robot costs about $1,000, comparable to a small suburban Canadian house. With just $3,000 yearly maintenance, these robots cut labor costs and boost efficiency. A robotic line can process 20 tons of salmon daily with only 5 workers. This efficiency is unmatched in the seafood industry. Workers earn $20.25 hourly, providing stable income during the salmon season. Advanced tech has cut product loss to 2%, versus 10% for manual operations. This improvement boosts professionalism and strengthens Canada's salmon exports to key markets like the US, Japan, and Europe. Maintaining consistent quality is crucial to earning customer trust worldwide. In the nut industry, almonds and avocados are central players due to large-scale production and high global demand. Recent reports show almonds are the fastest-growing nut, with California producing 80% of the world's supply. This state, along with China, also dominates the avocado market. Cashews, another nut, require different processing due to toxic chemicals in their shells. That's why they're pricey when exported to the US, with 1 pound of whole cashews selling for over $16. So, how do these sugarcane farms and processing facilities work? Let's take a closer look in this video. First, we'll visit an almond farm. California almonds thrive with temperature differences of about 58 to 68 degrees Fahrenheit, or 14 to 20 degrees Celsius between summer and winter. Experts estimate it takes about 1 gallon, 4.6 liters of water to produce a single almond. With modern irrigation, California produces over 2.5 billion pounds, 1.1 million kilograms, of almonds yearly. At harvest time, machines called shakers attach to each tree trunk, vigorously shaking almonds to the ground. Farmers let almonds dry naturally for 4-7 days before using sweepers to collect them for processing. This prepares the coffee cherries for a separate sorting machine with sensors that remove most debris. The cherries are then sent to large storage facilities, where they're fumigated for 2 days before processing. The facility handles over 20,000 liters or 9,072 kilograms of almonds daily. Once the almonds are cleared of debris, stones, and shells, the hulling process begins. The almonds are vibrated and tumbled repeatedly so the nut inside easily separates from the shell. They're passed through holes designed so only the nut can pass through. This process is repeated about 8 times with smaller holes to ensure the shell is fully removed. Next is the sorting process, which is done both by machine and by hand. The almonds are sifted through vibrating screens by size, using perforated collection methods, then sorted by optical machines. Once approved, the remaining almonds are packaged and sent to various factories to create a wide range of almond products. You know why they're coating millions of these almonds in chocolate to make the outer layer of countless ice cream bars. We're in an ice cream factory where almonds are key to making the ice cream more delicious and the eating experience more enjoyable. This chocolate-coated ice cream is very cold, so once it melts, the outer layer immediately starts to soften. After that, the ice cream is packaged. To prevent melting, the entire ice cream production process must be kept at a very low temperature. Would you like to spend a day working in an ice cream factory? In some areas, ice can be extremely cold. Almonds thrive in Mediterranean climates, like those in California and China. Unlike almonds, which rely on bees for pollination, these trees are wind-pollinated. Another key difference is that they must be harvested soon after pollination, not stored like almonds. At season's end, when almond hulls start to split, farmers begin the harvesting process. Again, shakers are used to vibrate tree trunks, releasing thousands of nuts in seconds. After falling, they're swept into rows by a sweeper and collected by a harvester. Each plant typically processes about 1.6 million pounds or 726,000 kilograms of nuts during harvest season. Using a similar vibration sorting system, the plant separates whole nuts from halves at the end of the production line. The nuts are then cleaned and air-dried in large coolers to reduce moisture content to about 8%, ensuring they stay fresh during packaging and export. Now let's explore the nuts you've been waiting for. Unlike apples and avocados, cashews thrive in tropical regions with warm temps and consistent climate year-round. That's why